Okay, we're going to get going at 4:15 sharp. This is actually a follow-up talk to one that we did on November the 10th. We're going to do a little bit of an overview with regard to what was covered with regard to the good, the bad, and the ugly of data management. I am David Redden, the director of the BIRD, which is the Biostatistics, Epidemiology, and Research unit within the CCTS. And I want you to understand that this is a joint presentation between many groups. Dorothy Ogden will lead off, Assistant Professor of Library Resources or Library?
Assistant Professor and Reference Librarian.
Reference Librarian, I'm sorry I got that wrong. And to set the stage, we're going to go over all the components of data management and flesh them out, talk about many tools that are freely available online. Later, as we go through, some of the the leaders of the larger units of the data management centers on campus will join us. But what I need to set the stage with right now is I want you to understand data management does not begin with the question of what software am I putting my data into. That's not it. It's kind of like coming and asking for a power calculation before you start specific aims. You can't get it out of order. The first key, so we're going to go through all these components. Then I'm going to give you a teaser, and I'll give you a teaser right now, coming in February, March, April, and May of next year. There are going to be 4 workshops drilling down on the components that we cover here into greater depth. They will be workshops held on a Friday afternoon over in the Learning Resource Center. And with that, I'm going to hand it over to Dorothy, and then she'll hand it back to me in a little bit.
All right, thank you for that introduction. So as we mentioned, we're going to discuss research data management across a lot of different types of research and really talk about common principles and things to be paying attention to as you get started with this. So we have the teaser about the workshops. As we go through this, please do be ready to make suggestions for future discussions or to jump up and say, we do that, and I want to know more information on what a best practice is for this thing, or I didn't even know that was a question I could ask. What can you do for me in the libraries or in the other centers here on campus? So we mentioned this is a joint effort. Myself and my colleague Kay Smith, who's a professor in UAB libraries and the lead research librarian on campus, have been a part of this, as well as Madeline Gibson, who I see in the back by the Christmas tree. Dr. Chaplin, who couldn't be here today, I don't think. Is that correct? Mm-hmm. And then David Snyder, Associate Dean in Graduate Biomedical Sciences. So research data management. What we mean about this is at a high level is a series of best practices designed to maximize and protect the quality, utility, and completeness of your research data. For those of you, is anybody familiar with the FAIR acronym here? So that's a principle that's been developed recently. It stands for findability, accessibility, interoperability, and reusability of research data. So as we're able to generate larger and larger volumes of data from our research, how are we going to make that findable and reusable, not just in our department or in our campus, but throughout our fields? And also, how are we going to make that reproducible long-term? Because we'll get to a point in the next few years where it's just as common when you publish a data set as it is to submit an abstract. And so what we're trying to plan for in talking about these things now is how we'll make that data accessible in the short and the long term and make it the most accessible. So with that part of the data lifecycle, it really starts with project planning. So as Dr. Redden mentioned, not just planning what software you're going to put something into, but before you ever start a project, deciding what you're going to capture. And that's what we mean when we talk about a data management plan. So what you're generating, what you're going to capture, the information that you'll collect about that, or the metadata that'll enable that information to be usable in a month, in 6 months, in 10 years. How you're going to save that, how you're going to control the versions of that data, because we rarely end up with the same set of information that we've started out with, even despite the best project planning at the beginning. How do you analyze that? How do you share that data? And that's when we get to presenting, to publishing, and to archiving long-term, and then also data reuse. So project planning. When you're writing your question, and you're doing your research data management planning, what are you trying to show? What are you trying to measure? How will you measure that? And then what are you capturing about all of those aspects? So what are you capturing in terms of measurements? How are those labeled? Not only how are you labeling those for analysis, but how are you labeling them and keeping information about them long term so that someone could reuse them who maybe wasn't even a part of your team, who's maybe using them 5 years down the road when they want to come back to the project. And that can be for all kinds of data. So we've got a list here of things that you'll see frequently. This is by no means a comprehensive list, and it can vary greatly depending on what field you're working in. Did you want to make a further one on that? Okay. And again, other types of data, so nominal, ordinal, quantitative. This can also apply to things like particular object data. So we deal with this a lot in libraries by talking about information objects, and that can be anything. That can be a photograph, that can be a file, that can be different elements of a Word document, it can be different elements in an Excel file, different pieces of a data set, different data files that don't necessarily work together. When we talk about data management strategies, one of the things we talk about is a metadata file or a data dictionary. A data dictionary is a file that defines all of the variables and all of the other pieces of things that you've collected throughout your project. And you save that with your research data so that if someone picks up your file in 5 years, they know how you coded everything, what the abbreviations for your variables were. So if you're trying to run numbers again years later, you're able to do that using this tool. But that's something you build, and you hopefully build it at the beginning when you're planning how to manage your research data. Key components of data management planning include data types. So again, that's where you'd be looking at what you're generating, how you're collecting it, how you're going to make it accessible long-term, contextual details. So the metadata, again, that might be information about, so if you're doing imaging, for example, information about what equipment you used to create that image, what file formats you saved it in, even where it was saved in, dates, things of that nature, if it's related to other data sets or not. Storage, backup, and security. So it's really easy, especially with small projects, to just say, I'll keep that on my laptop. I'll stick that on a thumb drive and it'll be fine. If anybody wants it, they can email me. And then in 2 years, you might move and that thumb drive will end up in the bottom of a box somewhere and it might not see the light of day for a long time. So with this planning, we want to go ahead and plan into the future for that. You might have it on a flash drive, but you also might plan to put it in a data repository specific to your field. And somewhere through NIH, there's a lot of different ways to do this. There might be institutional repositories you look at putting that in, and that way it's in a secure place that's backed up and it's managed. So you don't have to worry about going back to find a data set if somebody wants to see it 3 or 4 years after you've published it, and maybe people from your lab have moved to different places. These are issues that we try to plan for in advance when we're writing the data management plans, that we know how all this will get done. I mentioned storage, backup, and security, and we'll talk a little bit about versioning in a moment. You'll want to look at writing your data management plan. What's the institutional policy for the reuse of the data that you're generating? Because sometimes, we generate data, but it's not going to be released for whatever reason for a couple of different years. So what are you going to keep back? What is publishable or shareable? If you're keeping something back for whatever reason, how long are you going to do that? Is it indefinitely? Is there a limitation of 2 years or 5 years? How is that going to be handled once it does need to be accessible and findable? Yes.
So you've outlined the key components for a plan going forward.
Yes.
But if I wanted to start setting up this plan now, are there at least local solutions to where the storage should be in addition to the thumb drive in my pocket?
So I think that's a conversation going on in various places at UAB right now. I know there had been a look at something called a repository called Figshare about whether or not that was going to be accessible for campus. There are already lots of different repositories out there that you could potentially use to deposit something now. If you wanted to say, I want to make sure this is backed up somewhere, it's in a centrally accessible location, in addition to just having a thumb drive in my pocket, there's already stuff out there you can use, depending on where you're working. I don't know that we have a centralized place like that at UAB yet that everybody
So
can
perhaps
use.
Let me refine the question a little
Okay.
bit. What's the role of the institutional support of Box?
Oh,
Shall I repeat that
yes,
question?
please repeat that. Oh, the question was, what was the role of the institutional support of something like Box? I think you have an answer for this. I can tell you generally, like, so Box, you can put things in it, right? I couldn't get to anything in your Box unless you gave me permission. So yes, you can save things on it and it should be secure and backed up, but you can't save every kind of research data on like that. So for example, if you had patient-related data, you wouldn't want to archive that in Box. Or secure or private data like that. I don't believe Box is approved for that. And then it's also not accessible to lots of different people. So it's not it's a sharing tool, but it's a peer-to-peer sharing tool, as opposed to everybody in the research community come in and look at my Box file tool. And I don't believe you can do stable sharing through that long term.
So Box is not, with regard to Box, there is, with regard to Box, of course it is completely secure. With regard to the national repositories, once it's dropped in there, there would be it needs to be of the nature that it is prepared to be shared, because it will be publicly accessible. With regard to Box, would I use it for long-term storage with regard to any of the research projects that I tend to manage? The strategy I usually have with the research that I'm trying to manage for different groups on campus is to ensure that the archive is built completely for any abstract paper or any of the, I would say, monthly archives we build. But as we do that, they're backed up in multiple places. They're backed up secured to servers on multiple servers around the campus. But to my knowledge, we don't have a centralized repository that we have established yet here.
On premise.
On premise.
But, so part of this is, it would be helpful to me, because actually all these issues are pertinent to discussions I'm having every day, is to know what solutions are available today before the data is ready for archiving, for total sharing, because the initial project is finished. But how to handle data in real time, and then maybe within an investigative group to make that accessible, and perhaps someone with larger administrative rights, should it ever be necessary, can access to. So that's why I asked the Box question.
Okay.
You avoided the PHI answer, but probably can follow up on that.
Okay.
Hi, this question, his comments made me think about collaborations. I currently do research with UAB and the VA. The VA would never approve anything like Box. So when it comes to writing can we have maybe a seminar on writing a data management plan with collaborators across campus?
So with regard to, and that's definitely going to be one of the things that we bring up with regard to the February workshop, where we get together, the 2-hour workshop that we're going to hold over in the LRC. First one will focus on data management. The structure of these workshops is going to be 1 hour of kind of setting up where we are going through the very details, going into the whys. Then the last hour we'll break for caffeine and donuts, and then get back together for the next hour to make certain that we know how. So there'll be case studies that we'll all work on jointly and get that experience. Followed up from there, there'll be contact information for Dorothy, myself, other individuals, where when you want to apply this directly to your own research, we're there to give you some advice.
Okay.
Oh, we got another question.
All right.
I can be loud enough. Oh, I see. So I'm sorry, a couple of slides ago, you had a term in there, acceptable values. So as a bench scientist who does different kinds of research than some of the clinical folks, the data we get are the data we get. What's acceptable values mean? That was back on number
Are we there yet? I think that was my slide in the future, Tim.
No, it showed up. It was here.
Uh-oh.
Yeah.
All right, go down.
The slide before the last one we just saw.
One more. Nope.
One more.
Nope.
The next one.
There it is.
Okay.
All right, I'm gonna let you
Okay, I'll take that.
take that one.
So one of the things that we have to do a lot with regard to range and logic checks and things along those lines. It's one of the things, because there's nothing more frustrating for a statistician, and this happens all the time. You pass me a data set. Education level, right? Okay, I got numbers 1 through 9. And there's no documentation for what 1 may mean, 2 may mean. And then we're doing the analysis, and not only do I have 1 through 9, all of a sudden I have a negative 88. What's that supposed to mean? That's what I'm trying to get
That
to.
was me.
For those of you that wonder what negative 88 usually means, is missing. So, but that's just a standard approach in SPSS. But it's one of those things. So when I say acceptable values, I'm talking about as we're entering the data, what should those fields encounter? Can we put logic and range checks in there and limit what can go in there? And then again, there are plenty of times where there are just going to be unacceptable values that we need to be able to say, no, that does not make sense. If somebody sees it, we need to generate a query for it. That's what we're getting to. And even if that should be open range, then we still need to have a discussion with regard to that so that the people entering the data understand why it should be that way. Okay?
Okay. Other questions?
No, you guys were very helpful examples.
Okay, where are we? So research data management plans, I think right now there are a lot of the big funders require them, but they don't require it in a lot of detail. There are templates for most of those on this dmptool.org, or if you Google research data management at UAB, there's a website right now that has a link to this as well. There is a UAB profile there, and then they have templates for the major funders again, so you can start to fill something out. As we've mentioned a couple times, we are going to put together a workshop on how to do that for February. Steele gets a little bit more information. You want to switch off? All right, we'll just switch off.
Feels like wrestling, tag team.
I did want to mention as well, because somebody sent it in on chat, there is a link in box, a link for UAB that says handling restricted PHI data with UAB box, and it outlines that. So if we can figure out a way to maybe disseminate that, if y'all want that or need that to know what can go in box, somebody sent the link on the chat function, and we can share that if needed.
All right, that will be great. So the certain things when we start, and like I said, in a little bit, we'll have individuals, Nazmul, Islam will be here. I'm hoping that Chris Parks will also join us. But this is one of the things where we're going to get down in the nitty gritty of, okay, we're going to get our hands dirty. We're going to have to build this. We're going to have to record it. One of the things as PIs that you've got to start thinking about specifically is with regard to data acquisition and entry. You know, statisticians think of records. We think of a row within a data set. That's an observation. It could be for an individual. It could be for an individual at a given time. But usually the columns, when we think about them being the variables such as height, weight, all of those things. But one of the things that I have to, and this is David throwing David under the bus and backing it up a few times. Don't be lazy about it. When you're building a file name, make it descriptive, because you have to think about it. What if you have to pass this to someone else? And I'm going to start building on this example because it's the truth. On Friday morning, I've got a conference call at 10 a.m. I've got to pass 75 data sets and programs to an investigator I worked with for 7 years. They moved to South Carolina. We finally got the data use agreement where I can transfer all of their data to them. It made sense that they should have it. But think about that enormous task. Think about how many files, how much documentation there needs to be. The files should have been named in a far more descriptive manner than they are, and I'm correcting it now. When you're building file names, please don't put spaces. That will give future researchers in analytics nightmares at times. So think about that as you're building. If you can avoid spaces, that would be a good thing, especially when you're building variable names. There are a lot of people out there that say you should never use Excel for data. I'm not one of them. I think given the size of the data, the nature of the data, if it needs to be, it can be, but one advice is please do not use sentences as your variable names. Please, that can be a problem. You do need to keep it tight and neat, but please take the time to make it useful and descriptive.
Can I make a comment on that?
Sure.
So a comment about
The button on the bottom. There you go.
Thank you. A comment about that too is part of what the library component of this is we have resources we're getting together. So if you want to know what's the best practice for a file naming convention, we've got that for you. There are best practices out there in terms of what to include, what not to include, a length, how to pick those out, and how to implement them in your lab so everything is standardized. And that's a big part of what libraries are doing in this. So that's part of why we're folded into this talk.
Okay. Going forward, and now yes, Penny.
So quick question, and this is more about data names, data file names. Are you using CDISC? Oh, where's the button?
On the bottom.
Is that the right word? The FDA approved listing of data field names. CDISC? Does that sound familiar to you? David, you should know this. Come on, somebody knows this. If the FDA has approved a set of the file name, again, data field names, so that eventually in the far distant future, we can combine all of our data and it'll all be usable worldwide, so to speak. So are you all doing that? Using
I'm
those?
not at this time.
Okay, just curious.
That's something that, again, we would want to, why we're talking about this with the data management planning ahead of time, because it's something you want to design in, right? Say, like, we're going to use this standard, make sure everybody knows how to apply it. If there are questions, go to whomever, hope for the library, and we can look things up for you and get data for you as well. And we're trying to plan resources ahead of time in some of our research guides at the library. So if we know this is the standard everybody needs to have, we can set up a link to it. So if we get new students or new postdocs, we're like, someone told me to come to the library and get information, we've got that to give to them. And that speaks to the I interoperability and the FAIR standards as well. So good question. Thank you.
Other questions? Okay. The other thing, then we get to the point that, and again, I want to emphasize this, there's a data management life cycle. Most people think it starts with the decision of what's the database going to be? Are we going to put this into Excel? Or are we going to put this into a RedCap? Are we going to put that's never, ever really the first step. The first step always backs up to the idea of what's being measured. How is it going to be recorded? What's the nature of those variables? What's the logical value? What are the values and what are the range of values that it can take? But eventually we get there. Then it becomes a very key question. I would argue I'd like to pick the software based on its utility. I really do. And one of the things that's very important to me is to make certain that logic and range checks can be built in to the system so that as we're going through that there is not the ability, if I'm not to be allowed to put a negative value in, then we prohibit negative 88. So that those things are completely blocked and the quality of the data is improved. One of the things is that again, dates. Dates are the bane of existence for most statisticians because they come in so many different formats. Most of us don't remember the fear of the Y2K problem, but that was an issue, and ironically, I'm starting to get new data sets that are recording age with just 2 years, and I'm like, how quickly people tend to forget. So these types of things to be aware. So, and again, how will you format your age? We've had the issues before. We have data sets that came in from Europe, and all the ages all of a sudden we couldn't calculate the ages because the format was switched. It was 25/12/1969. The 25th month? Yeah, good year.
Good year.
Yeah. So those things have to be monitored. So to keep in mind, logic and range checks. So version control. Over the past several years, version control Data management has quickly evolved. Now, I cannot tell you the number of times I've had to roll back data sets or the need to roll back a data set simply because something went wrong in saving. Current version of the data is corrupted. That will give you a cold sweat very quickly. And also to keep in mind that you must maintain archives and backups. And there has to be, this is a key thing in your data management plan. When you are going through and developing that data management plan, you have to say, how often are we going to make a backup? Where will these backups be stored? Let me give you a hint, in more than one place. Do not just simply tell me it's going to be backed up at the School of Public Health server. Is that server mirrored? How many mirrors are there? How often is it backed up? How are you going to confirm that it's being backed up on the frequency that you will? How many times will you examine that backup? Old strategies were monthly, weekly, or daily backups. There's Git now, which is very interesting. It's one of the tools that we really want to illustrate with regard to when we go into data or version control, and that would be scheduled for April. Over in the Learning Resource Center is where it is allowed to, as you make changes, it records those changes directly and it allows you to back up. It's a very efficient way to do version control and rollbacks without building multiple versions and maintaining multiple versions of your data sets. Now here's a key thing. Friday, and let me put it this way, and here's David going under the bus again. Tonight and tomorrow night, I will be spending a lot of time building a metadata file for South Carolina. That metadata file should have been built many years ago, and it would have saved me a lot of heartache over the next couple of days. In the sense that to be able, the metadata file that I want to, whenever you buy new software, you always see the software, they always put a file in there that says readme, right? Readme.txt. How many of you read it? Okay, liars, bunch of liars. The metadata is very, I don't, but the metadata is this concept. When I get ready to pass this to this group in South Carolina, the code in SAS, the software that I've programmed all the analyses in, that code is very well documented. But there needs to be another file that says these are the following data sets. These were the data sets utilized for the following papers. These are the raw data sets. These are the cleaned data sets. Here's the code that cleaned the data. And here are the data sets that were associated with the final abstract or publication. That's what I'm talking about. When I think about a metadata file, that's what I'm thinking about. What is explaining the nature of the objects in the directory or in the archive? A master file that details each component, how they relate to each other. Because the last thing and I will have to do this also for the programs, because the last thing I need someone else to be doing is clicking through program after program after program, trying to identify which one of these produced that analysis. Much easier, much more efficient for there to be one file that they can scan and see this file, this program calls the following data sets to produce the analysis shown in this paper. That's what I'm looking for. So there's descriptive, there's structural, that would be the relationship. Administrative is who are the people accessing it, who had rights to it, all of those types of components. The metadata, the best quote I've ever heard about metadata, there's one key component I want you to think about. Metadata is simply a love note to yourself 10 years down the road. You will be very happy you did this, because there have been times I've come in on a Monday morning to have a PI call me and say, hey, the Cochrane Review wants our data for a meta-analysis. Oh, that's great. That was published 7 years ago. Who has the data? PI says, David, do you have the data? In a panic. To which I respond, yes, I have the data. You should too. Do you know where yours is? I know where mine is. And we're able to pull it, but that's a key component. Have the data stored not only, if you can, publicly, but put it in the hands, make certain that it's in the hands of the methodologist. Make certain it's in the hands of the PI. Make certain they have the metadata file. Make certain they have the archive. Make certain that multiple people have access to it. Okay? If you have done a reasonably good job of a data management plan and fulfilling your data management lifecycle, then and only then are you probably going to have a very easy time sharing all your data, which is what's coming. Data sharing and publishing, and I like the phrase with confidence, becomes much, much easier. However, I want to emphasize this, when publishing anything, whether you're sending in an abstract, you're sharing a figure, you're getting ready to submit a paper. I mean, I won't ask for a show of hands, but how many times have people submitted an abstract, submitted a paper, gotten positive reviews, then had questions about some of the things in that paper, and then you start scratching your head saying, well, why can't I easily put my hands on where that p-value came from, or where that figure, or what samples produced that figure? Those things need to be avoided, and you can do that with regard to building a very good archive as you're submitting the database, as you're submitting your paper or abstracts or figures. Key thing, you have to be able to identify those final sets and archive them together. And the whole point about building an archive, you've heard me for 2 years now, over and over, emphasize rigor and reproducibility, And there's a great debate about what the term reproducibility means. But no one can deny that one of those definitions is the ability to go back and say, under these conditions, this data was collected, and here are the data that created these results. Okay? You really do need to ask these questions with regard to short-term storage. Where is it being studied as the study is ongoing? How is it being backed up? But honestly, a more important question that everyone needs to start to grapple with more and more. This is to be on the cutting edge of research. There are people diligently trying to answer these questions. But how do we know, and how comfortable can we be with regard to where the data is going to be stored, and can we get to it in 10 years? Very early in my career, it was very interesting. We were doing a study, and this indicates, and this is an interesting thing, and then I'll throw out one more tidbit. In a very early study I was doing, there was a study of early child care, a very prominent study. Could not be analyzed correctly by modern standards because the statistical methods hadn't been developed. But out of curiosity to try to assist somebody with their dissertation who wanted to use these new methods, we reached out to the lead statistician in the PI of this study that was developed. They could not access the data. They couldn't get it to us. It had been 10 years, but no one had access to the data. The data was gone. One of my favorite stories, and this is no joke, the greatest accomplishment of science, in my opinion, Apollo 11. The original telemetry data, it's gone forever. There was no archiving. There was no storage plan. It's gone. NASA cannot find it. The original images came in high definition. They're gone. What you saw on national TV was dumbed down, but they can't find the originals. Okay, so the question is, how are you going to store it? Yes?
So, David, I actually have two questions. The first is, I've been in your office, and I've seen 3.5-inch discs. I've seen 5-inch floppies. And so I'm wondering, at what point do you look at these and say, oh my gosh, where am I going to find a disk drive that's going to be able to run these files? So what is your suggestion on how we can evolve with the current technology to make sure that we don't accidentally have valuable stuff on things that just can't be read?
And that goes back to, thank you, Jennifer, that goes directly back to that comment about data management. By the way, that was my dissertation you saw. It comes back to having that data management plan, to being able, and that's one key component. That's the last piece of it. How are you going to archive it? And there should be a strategy within there to state, are you going to every 2 years evaluate and consider moving it to new medium, to new standards? Public, and as are you going to monitor to see if new public repositories are going to come online? That would be appropriate places to study that. That was question one. What's question two?
The second question I had is essentially related to your suggestions about backing up your data in multiple places. And so if I have a file, for example, and I save it in site A, site B, and site C, and then I go into site A, I tweak something, I version it to a different version number. Now I have it here. But what if my collaborator goes into site C and does something to their file and increments the version? Now we have two competing versions. How do you keep this? Is this are there efficient ways to make sure that you're keeping things in multiple places, but yet you're keeping track of the evolution of those files longitudinally?
The software that we're going to illustrate within the April workshop.
The Git?
Yes, the Git will help you be able to do that.
Cool.
That way, where multiple people are touching one file, the ability to control versions across multiple people and across multiple files.
Fantastic. Well, I think that could come in handy, not only for the data analysis.
For administrative stuff also.
For everything that we do. Exactly. So I'm pretty psyched about that.
Okay, you're going to be there.
Thank you.
All right, I'll get the flyer out to you as soon.
Careful, you might give Andy a heart attack.
Question online.
Question was, once you have multiple copies, how do you ascertain which was the one really used in the publication?
Okay, that is a great question. I will repeat the question for everybody to hear. So once you have multiple versions, how do you ascertain which one was the one associated with the publication? Well, I can only speak for David Redden, but one of the things I will do when I am collaborating across with PIs is when we are about to hit the submit button with regard to this is going in to clinicaltrials.gov as documentation of the data, or this is going in for publication to JAMA, there is that archive. And it states archive, date, final submission to. And within that document, you will see final graph, figure 1, final graph, figure 2. It has to be a proactive strategy because I am not afraid to back up the bus and pull it right back over myself because I have been in that situation with the cold sweats of, oh, dadgummit, there are 3 versions of this. Now, which one did I give them? And you can't, you've got to avoid that with a very stringent and dedicated data management plan. Now everybody in the room is laughing at me. How nice. Now to get back to Jennifer's point, and this is something, again, I have to emphasize and why I think there's such a push on the campus to assist with multiple groups coming together to assist with this. Data management is probably the most labor-intensive thing I've ever done in my life. That beats out all the analyses, everything else that I tend to do. Data management is labor-intensive. It is perpetual. It is something that is ongoing and requires great attention with version controls, the case report, completeness, accuracy, all of these things. And you can't do this by flying by the seat of your pants. That's why the very first thing that's why the very first thing we're going to do in February is assist everybody with, this is how you write a solid, succinct, don't want these to turn into massive tomes of information, but very good data management plans. Okay? So please look for those announcements that are coming. The other key thing is to remember with regard to, we don't want you to become experts. You don't have to, you can get plenty of guidance, but there's also expertise on this campus on building very good structured database management systems. That includes the biostats and bioinformatics shared facility. We will send all the slides out, then they'll be posted. up at Preventive Medicine, Nazmul Islam in the School of Medicine, Chris Parks within the School of Public Health within Biostats. Research Commons will be glad to give you advice. The Bird will be able to gladly assist you. The Lister Hill Library with all the abilities to do this, to get you to the resources with regard to finding published data management plans to assist you, getting access to tools. So as I said, here's the teaser. Couldn't do a movie trailer, but here's your teaser. We'll be writing a data management plan in February. Hopefully we'll lock down the rooms and the dates tomorrow and start building the flyers for that. Establishing a metadata file, how to do that. Methods of version controls, tools for version controls. And then there's been curiosity around the campus. We got somebody smiling already about electronic lab notebooks. To do all of those, we'll run those hopefully. We know there's no hope to it. We will run those in the spring and then hopefully circle back, learn from our experiences, and run them again in the fall. Okay? And the other thing is a large amount of information if you wish to find the site on the UAB or the webpage where you can find all of that stored information. This talk will be placed on the CCTS webpage. We will be here for a little while to take questions. And with that, that's that. Right at 5 o'clock. Wait, we have one more question.
So the gentleman who asked had a follow-up for that really quickly. And he said, what I meant was even beyond which version is in your archive, but once the PI has the copy and the stats guy has a copy, how to validate which is the most current and correct. I assume that's going to be the software that you're talking about.
That'll be through the software, but it's also a matter, again, I will be very blunt, and I hope this does not sound like a glib answer, but there has to be that communication and an agreement that this is the most current, that if any requests come back in with regard, because we still, especially with statistical methods papers, questions will come in. If it comes into any of the authors, it is distributed to all the authors. All of us agree where we're accessing the simulations or the data. And then once that has been done, everybody receives the updated copy. Okay, other questions? All right.
So David, let me, for those who want to create a data management space, I understand by May of 2018, we may have the tools in hand. But what if our timeline is December 18th rather than May 2018? What can we do?
I actually think the best first I'll hope that we can make the May 2018, but if we do not make that deadline, I think what the best I would like to be able to do is to get all the experts together on campus with regard to Nazmul, Chris, Dorothy, all the individuals together to come up with a strategy. There's no reason that we cannot develop a data management plan. Data management plans can be focused with regard to projects. They can be focused to more global areas, to work out an archiving system, to go across multiple studies. That would be the best I could do.
So can I ask, you say data management space, what are the features of that you have in mind? Are you thinking of like a collaborative space where different people are able to work on the same sets of information? Are you looking for something like a standard? So my follow-up question to the question was when you say data management space, I was asking, I'm sorry?
Which version?
We'll go with 2, and I'll make a note of that in the dictionary later. But are you thinking of something like a collaborative space where you want multiple people to be able to work on the same set of data? Are you thinking about something like a standard that'll denote, like, here's how we're going to do file naming, here is an ontology that we're going to use to describe, things like that? I'm just curious to hear what you had in mind.
So I actually do have a specific case in mind where the issue is bringing together data from multiple sources some of which have been very carefully version controlled, perhaps not all of them have, but to bring them into a single space where then, yes, people can collaborate, but also any updates to those as the data is refined and QC'd can be kept track of. Right now, there's not an environment, a digital environment to do that. And the timeline for that truly is December 18th, not May of 2018. So that gives us a couple of days, and I would welcome your suggestions.
All right. With that, if there are no more questions, there's plenty more food and a few more drinks back there, and we'll all be here for a little bit to answer questions.
David, thank you very much. We do appreciate it.